In the previous video, I talked a lot about speed, velocity, accelerations, and also distance displacement. In this video, I'm gonna have a few conceptual problems for you to solve and to test to see if you actually understand concept development, speed, and velocity. Number one, suppose you travel three different paths in the same amount of time to the same destinations. Which path has the greatest speed? And the hint is below. Average speed is distance traveled divided by time of travel. You may pause the video now. Alright, so like I say, which path travel has the greatest speed, and speed by definition is distance travel divided by time. So we look at the distance. This one have the highest, the largest distance. As you can see, the path it take is kind of curvy right here and get to destinations. So greatest distance divided same amount of time. So this will have the greatest speed, and then this will be the lowest speed is path A, because the distance from here to here is not as long as from here and take that path to there. Suppose you drive on three different paths in same amount of time for 20 seconds. Which path has the smallest average speed? Which path has the greatest average velocity? Pause the video, see if you can answer the questions. Let me try. So the first question is which path has the smallest average speed? And again, would be path A, because speed is distance divided by time. So path A will have the smallest average speed. However, they are gonna have the same average velocity, because velocity is not looking at distance, but rather look at displacement, just from here to there, from here to there, from here to there, have the same distance, displacement. So you have same displacement divided by same amount of times, will give you the same average velocity. And again, the speed from smallest to largest is A, B, and C. Average velocity are the same. What are the three controls in a car that affect its accelerations? If a car has no acceleration, what do you know about the car motions? If you have a lot of trouble answering these questions, please go back to previous lectures and watch that. You may pause to answer the questions. So the answers, if you are accelerating, which means there's change in velocity. So the thing that changed the velocity of the vehicle is the brake, the gas pedal, and the steering wheel. The steering wheel changed direction, so therefore there's a change in velocity, because acceleration is by definition velocity over time. So those are the three controls that affects acceleration of the car. If a car has no acceleration, what do you know about the car motions? Well, a lot of students have a tendency to say that, okay, the car has no acceleration, which means the car is not moving. Well, that's not true. It can be true. So if car not moving, of course, it has zero acceleration. But also the car, when it's moving at a constant velocity, then it's not accelerating. So I'm going down the highway at 60 miles per hour east. Then my velocity is not changing. Also, by definition, there's no acceleration during that time interval that my car travel down the highway. Can you move right and have the left accelerations? Pause the video and see if you can answer that. Alright, so the answer is yes. Okay. In order for you to slow down, if you're going right, your acceleration must be left in order for you to slow down to complete stop and then turn back around. Okay. Suppose you jump off a coconut tree and into a river. What is the direction of your acceleration right before and after you hit the water? Pause the video now. Okay, so Before you hit the water, the acceleration is downward. If you remember from my lectures, it's approximately 10 meters per second square downward. Okay, so direction of acceleration is downward. When you hit the waters, the net force would be upward, slowing you down. Okay. Here's more concept questions. Why do we put trees near the roller coaster rides? Why do we make movies of flying airplane during cloudy days? Pause the video now. Okay, so the reason why we put trees near the roller coaster ride is because it gives us a perception of speed and it gives us that wow factor. Wow, this roller coaster is moving very fast. Because if we don't have reference point, then things will move very slowly. For example, have you ever ride an airplane before and you look down from an airplane and there's no cloud at all? You will see that the airplane seems to move very slowly because your reference point is the ground, and it change very little. Even though the airplane might be flying at 500, 600 miles per hour, your perception of speed is not very fast when there's little reference point. So in the case in which we were trying to make a movie, of course airplane are flying, and that's the same reason you need cloud to have certain reference points, so it gives you the perception of speed, give that wow factor. This airplane is flying there and all over the place shooting each other. But if there's no cloud, it's just boring. It seems like the airplane is not moving at all, nothing interesting, no action. So that's why a lot of people that are making a movie, they know that, they realize that, so they always making any flying objects, whether it's alien spaceship or whether it's you know airplanes shooting in World War II or something like that. They always have to have some kind of stuff around it to give a perception of speed. This one is a little bit challenging, but if you're able to solve this, you're in good shape and you can go ahead and move on to the next video. The question here is, when the 100 km/h car are 200 km apart, a robot begins running from one car to another at 300 km/h. When it gets to the other car, it abruptly turns around and run back and forth trip until a Tesla. Oh, I shouldn't say Tesla. I misspell here. This should be a car. Meet and crash into it. How many kilometers did the robot travel in a total back and forth trips? So let me explain to you using this picture. It's better to understand with the picture. As you can see here, this car is moving right and this car is moving left. This robot is trying not to get hit by the car and it's running from this car to over this car and back and forth like this. While this car is trying to squeeze it together right in the middle where two cars will crash into that robot. And again, so in here we make a major assumption that the velocity of the speed of this robot is constant, doesn't change at all, uh, uh, and the speed of the vehicle also doesn't change. Of course it does, but for this problem, assuming that this robot is running at 300 km back and forth, okay, until it die in the middle. So pause the video and see if you can solve that. Okay. So in order to solve this problem, you just need a little bit of math, not big deal. First, you have to ask yourself, what is it that you need to find? And right here, you notice that you need to find the distance that the robot travel. Okay. And given the car is going at 200 kilometers, and so therefore both car will meet at in 1 hour. So if this car is moving 100 kilometers per hour, this car is moving 100 kilometers, and they're 200 kilometers, so therefore they're gonna meet right in the middle. Okay, so that's the total time. But all the same, also the time is also the same for the robot traveling. So by definition, distance is equal to time multiplied by the speed, average speed. And so you have 1 hour, and the robots just ran back and forth at 300 kilometers per hour. So 300 times 1, you get 30 kilometers for the distance. So say, what? 1 times 300 is not 30. I know. I say it's 30. embarrassing. So just some fix my mistakes. One, some 300, this should be 300 kilometers. Some very embarrassing arithmetic mistake. But that just proves I'm human. I make mistakes. Get over it.